Alright, so we're in section 7.5 where we're going to apply properties of logarithms. So as we're looking at it, we have three properties of logarithms. We have what is called the product property, which means that if, say, we had a log base b of m times n, I could rewrite this. I could rewrite it as log base b of m plus log base b of n. So if you have a product that is in our logarithm, you can add those two together. Same thing goes for the quotient property. To have log base b of m divided by n, I could rewrite this as log base b of m minus log base b of n. The power property comes from the exponent. So say I had log base b of m to the n power, you could rewrite that and put it as n times the log base b of n of m. So our first examples here is they give us they evaluate two separate logarithms, which is going to help us solve our logarithms in our examples. So they're telling us that log base 3 of 12 roughly equals 2.262, and log base 3 of 2 equals roughly about 0.631. Okay, so, and that's going to help us out in being able to determine what these examples are. So let's look at example A. I have log base 3 of 6. Now, how could I use these two values to help us out, but then also use our properties of logarithms to evaluate these particular problems? Well, 6 also can be written as 12 divided by 2. So let's write that. So I'm going to go log base 3 of 12 divided by 2. But then we remember we can use the quotient property and rewrite this as log base 3 of 12 minus log base 3 of 2. And then this is, we know that 12 is roughly 2.262 minus 0.631. Take the difference of those, and it's going to be 1.631. Okay. Now, if I have log base 3 of 24, I can rewrite this as log base 3 of 12 times 2, which then I can then use my product property saying that it's log base 3 of 12 plus log base 3 of 2. So then here it's just taking 2.262 plus 0.631, and then we'll get 2.893. Okay. C, I have log base 3 of 32, and I can rewrite this as log base 3. I know that I can take 2 and put that to the 5th power, because 2 to the 5th power is 32. And then I can use the just the power property, and rewrite this as 5 times the log base 3 of 2. And then I can just say 5 times 0.631, and this is equals about 3.155. Okay, and other examples that they're going to want us to do is use those same properties to help us either expand or condense logarithms. Expand logarithms is be able to take it, take several logarithms and expand them out. Condensing them means is that you've had an expanded formula and you're kind of doing the reverse of it. So I'll show you how that works. So I have log base 7 of 3x squared divided by 5y cubed. Well, I guess the first thing I'm going to do is I'm going to take care of that quotient. So I'm going to rewrite this as log base 7 using the quotient property. So then I got 3x squared minus log base 7 of 5y cubed. So now here, you may not see it right away, but this is actually meaning that it's 3 times x squared, and this one is actually saying it's 5 times y cubed. So I can use the product property for those. So now I can rewrite this as log 7 of 3 plus log 7 of x squared minus log 7 of 5 plus log 7 of y cubed. Last thing is I got exponents. So now I can use the product or the power property, and then so I can rewrite it as log 7 of 3 plus 2 times log 7 of x minus log 7 of 5 plus 3 times log 7 of y. And that is the expanded version of my example A. If I have something like B, I can use the same strategies. Everything's the same except it's just the natural log. So I can rewrite this as the natural log of 36 plus the natural log of x to the 4th plus the natural log of y to the 6th. And then I got my exponents, so now I can use the power property. So then it's natural log of 36 plus 4 times the natural log of x plus 6 times the natural log of y. And so that is the expanded example for B. So if I didn't have an example for a condensed, but it would be something kind of like this. Let's say that it was an expanded view like log base 4 of 7 minus log base 4 of 10. And then you're just doing it backwards, so then it would, the condensed version would be log base 4 of 7 divided by 10, because you're just taking the quotient property of that. So that would be a condensed example there. Last thing here is the what is called the change of base formula. You can say that if you have a log base C of A, this ends up equaling log base B of A divided by log base B of C. Could be any, as long as B and C do not equal 1. And if you have yourself a common logarithm and natural logarithm, it can be shown up as this. So if you find yourself needing the change of base formula, you can just punch this into your calculator and be able to evaluate an expression, because you can use log base 10. So here I have log base 5 of 6, so that means I can just rewrite this as log of 6 divided by log of 5. And when I punch this into my calculator, I roughly get something about 1.11. If I do this for B, again, it's going to be log 54 divided by log of 4. Punch this into my calculator, it's about 2.88. Here I can write this as log of 3 divided by log of 12, and then this equals roughly 0.44. And the last one, I can say log of 5 over 11 divided by log of 6, which in this gives me a negative 0.44. Okay? And that is how you apply properties of logarithms. Hope this helps. Until next time.